Beginning Log 4. This is Carson Isaiah Shen again, head of the Mech Propulsion Systems Lab owned and operated by Aegis Mechatronics. This is my 4th log for work we've done towards the Peculiar Robot Contest, or PRC. The Fighting-Directed Laser Armament Mech, or Fidlar, previously obtained its primary laser cannon, so now we will work on auxiliary components such as the secondary guns and manipulation arms. The alpha-voltaic battery modules are still delayed, but we've received confirmation that they are en route, so we'll do what we can and wire it all up later. In the meantime, we have to rebuild a 4th shoulder for the mech, so I'll be glossing over the details. Just like on the primary cannon side, the secondary guns need to be mounted 90 degrees from where the placeholder mock-ups were attached. Cold fusion photon welding was used again for a stable mount, even though the secondary turret will have significantly less mass. It's better to keep components consistent and hot swappable. We also reused the same armor plating from the first arm and the legs, although minor tweaks are needed for this slightly different form factor. After a lot more welding and grinding, we're finally done with the last limb on the Fidlar, which is a great milestone to get behind us. A magnetic attachment system was quick to install for the turret. The secondary turret will be based on a refitted dual-barrel autocannon configuration, undergoing a comprehensive reconfiguration to integrate seamlessly with the mech's existing energy weapon systems. We're going all in on trusting the Fidlar armor to protect the electricals in combat. That means we can use more electromagnetic rotors for aiming this turret. Due to the high rotational inertia of the rotors, the incorporation of braking mechanisms, such as brake pads, is essential for achieving precise control over deceleration and stabilization. Mirroring the other arm, another small armor panel was added. Lower tolerances for ballistic weapons presented a unique challenge, and a lot of cleanup to make the housing energy weapon compatible. This directed energy weapon will not use laser technology like the primary cannon. A quick mock-up suggests our idea will work with parts on hand. The turret will employ a coil gun-based design, utilizing electromagnetic forces to propel superheated plasma projectiles at high velocity. Due to the extended cooldown necessitated by plasma manipulation, the dual-barrel configuration facilitates alternating fire sequences. This approach effectively doubles the system's effective firing rate while adhering to thermal management protocols. While the Fidlar's primary function is combat, the Mech Propulsion Systems Lab acknowledges the potential value of environmental manipulation capabilities. However, due to the focus on core combat functionality, the lab is prioritizing a compact and unobtrusive design for environmental manipulation systems. This will be achieved through the implementation of high-precision machinery. While various approaches exist to achieve the required degrees of freedom, magnetic attachment points consistently offer the most compact and potentially space-optimized solution. The manipulator arms will be affixed to the forward section of the chassis in order to optimize operational clearance and storage when not in use. Further analysis revealed the necessity for significant modifications to ensure compatibility with our design specifications. Our lead machinist became ill, so we had to contract parts from the vendor Fast Draft Machining, or FDM for short. FDM's parts are always terribly crude, but the cheap cost and inhuman delivery speed of duplicate parts is necessary after losing countless work hours. Given the recent security incident at the laboratory, the machinist's food poisoning is undergoing a thorough review to rule out any potential tampering or malicious intent. So far, still no culprits have been identified. Hopefully, this time is just a case of bad luck and unrelated to previous sabotage against the Mech. I'm more concerned with the machinist's removal from the lab for consuming food other than the government-mandated nutrient paste, which definitely never makes citizens ill. I'm not saying they have, and I have no evidence to suggest otherwise. Our machinist exemplifies qualities that demonstrably align with Aegis Mechatronics' high standards, but I digress. Utilizing FDM's made-to-order parts, along with our existing machined components, has facilitated the delivery of our targeted compact design. Electromagnetic latches help secure the manipulator arms to stay locked during transit. The arms function well, but the attachment point is undersized for their weight. This issue was resolved by utilizing a wider surface area with brake pads, similar to the secondary turret mount. While the lead machinist was out, the rest of the team took on whatever odd jobs were available and could be executed to fill work capacity. They are capable workers on their own, but they could still use more experience on projects this technical. Open tasks include integration of additional armor plating and the fusion powertrain components for the Fidlar unit. Thankfully, our in-house master welder is not sick, and they were able to secure components as they were integrated into the system. Paneling over open areas with sheet metal to keep out dirt and moisture is a simple but necessary task. The affordability of certain components allows for the implementation of cost-effective redundancy. One final bit, and the engine system is ready for installation of the alpha voltaic battery modules. A new technique, combining cold fusion photonic welding with talcum-based filler, proved effective on all small gaps and low-quality welds. Speaking of gaps, the primary laser cannon has many that I have not been satisfied with. It's easy to overthink processes while building, but sometimes the simple, fast solution is the best. With a full seal around the opening of the claw armor, my last request to the team was to protect the magnetic latches on the rear of the pivot. Once in a while, a material needs to be annealed with flames to allow proper welds to form. There's still a lot to do with electronics, wiring, hydraulics, tubing, and so forth, so I'll have to take some time to plan this out for the lab team. We'll be open to addressing questions or concerns on behalf of Aegis Mechatronics. Attached is footage of the current Mech status. Feel free to leave your comments before the final audit is submitted later in the year. It's been a busy 2 weeks. On to the next 2. New benefactors have joined the cause. This is the end of Log 4.